Okay, so we're going to go over 2.1 and then just a couple questions. So starting with number 7, it's asking, it says, given that f of x is 3 to the x, what is the inverse of x? So remember we talked about the inverse of it is what undoes it. And so for the inverse of exponentials, it's going to be the log of that. Okay. So for this very first one, number 7, the inverse is going to be what undoes it. So I'm going to basically rewrite 3 to the x in terms of logs. So that's going to be log base 3 of x is your inverse. Okay. Okay. So similarly, number 10, given that f inverse of x is log base 10 of x, what do you think f of x would be? Right? So how do you undo? Yes, very good. How do you undo log base 10 of x? It's going to be 10 to the x. And just keep that in your brain. Like it's still new. It feels still new, which is right. Right. 10 to the x and log base 10 of x are inverses of each other. Multiplication, division, adding, subtraction, squaring, square rooting. Right. These are all undoing each other. So the inverse is exactly that. It's what undoes it. Very good. Okay, the next question you asked was number 21 for go. Oh, wait. Oh, no, 15 through 17, sorry. For 15 through 17, you said, I don't know what I'm supposed to do here. So the directions say, given that h of x is 2 to the x and k of x is the inverse of that. Okay. Use the graph of 2 to the x to find the missing value in each equation. So this is 2 to the x. So let me just label that there. So it's a little bit easier. So this is, oh shoot, is this h of x? Yeah, h of x, which is 2 to the x. And then I think they said k of x, right? K of x. Yeah, k of x is h inverse of x. So k of x is equal to h inverse of x, right? So remember that whenever you're looking at a graph, and this is what I saw from some of my students, remember that the inverse means to switch your x and y. So inverse means to switch. Oops, that doesn't say switch. Switch x and y. Okay, so what does that mean? So it says h inverse of what gives me log base 2 of a half equals to what? Okay, wait, what? So let's look at this part right here. So this is its own little guy. So log base 2 of 1/2. Let me write that to the left really quick. Log base 2 of 1/2. I said 1 to the half. Sorry. Log base 2 of 1/2 is equal to what? Right? That's what they want to know, is equal to what? So the very first thing is, because you all are still getting used to talking in logs, my suggestion is that you rewrite it using exponentials, right? So let me get this a little bit more synced, a little faster. There it goes. So I'm going to rewrite this using exponentials. So exponentials means I take the base 2, I take that base 2, and then I take this answer here, which I don't know what it is. So I'm going to put a little box. It's this guy right here. And then I say is equal to 1/2. Notice the 2 base here is the base here. The answer of the log here is your exponent here. And the argument is the answer for your exponential. So kind of like learn how to translate from logs to here, because then it's going to make a little bit more sense. Okay, so 2 to the what gives me 1/2. What happened to this 2 to give me 1/2? So hopefully you're saying, yeah, it's divided by 1. Exactly. It's that negative exponent. So my answer here is -1, Miss Johnson. Yeah. So I'm going to put a -1 in the exponent. I'm going to put a -1 as my answer to the log. So that's what this gets here, -1. Okay, that gets -1. Now it's saying H inverse of what number gives me -1, right? Gives me -1. Now, if you notice H inverse, if H of X is 2 to the X, what's the function? What is your function of H inverse? So I'm going to say it again. If your function is 2 to the X, H of X is 2 to the X, what's the function of the inverse? What is that function? So remember, we just talked about this up here. We said if it's 3 to the X, very good, very good. If it's 3 to the X, then the inverse is going to be log base 3 of X. So very good. You wrote it in the chat perfectly. So I'm going to write that here, log base 2 of X. Log base 2 of X. Okay, so if H inverse is log base 2 of X, log base 2 of X, what's your X in this case? What's your X in this case? Oh, it's just 1/2. Yeah, so they want me to write 1/2 here, Ms. Johnson? Yeah. And notice if I look at the point, this point right here, -1, comma 1/2. I don't know if you could, yeah, that's good. So that point there flip-flops for my inverse. Notice the answer is the X. And the Y, this guy's Y, is what I'm plugging in as X. So notice they switch spots. This guy goes here, this guy goes here. That makes sense because that's exactly what we said. We said that inverses switch your X and Y's. Okay, so same thing goes here. You're going to continue all the way through all of these problems, and that should make a little bit more sense there for you. Okay, the next problem you said was number 21. Oh, this one. Apply the properties of exponents to find equivalent numerical expressions that no longer have exponents. Now, this one's a tricky one. Hold on. So this one's a tricky one. And the reason why it's tricky is because this negative right here is not seen by the exponent. This negative is not seen by the exponent. What do you mean, Miss Johnson? So I'm going to have you look at -3 to the -2nd versus -3 to the -2nd. So here, I want you to compare with and without parentheses, and it's going to come together pretty soon. So when it has parentheses, it's not going to show up. Give me a second. Okay, so when it has parentheses like this -2 applies to the whole thing. So Miss Johnson, you want me to divide because it's negative 2 times? Yes. By -3? So this actually looks like this, right? This is 1 over -3 times -3, and it's divided 2 times, right? So that would equal to 1/9. Versus, okay, now this one is different. This one only is applied to the 3, not the negative. So the negative does not get squared, if that makes sense. So the -1 stays on top, and I divide it twice by 3, not -3. And if you don't understand why, it has to do with PEMDAS. PEMDAS says take care of exponents first, then multiplication. But Ms. Johnson, this is a -3. Yeah, but when it has an exponent like this, it's actually -1 times 3, or the opposite of, right? So here, do you see the difference between the two answers? This one on the left is +1/9, and the one on the right is -1/9. So the way I tell my students is like this. It goes, exponents are always nearsighted. They only see whatever's directly in front of them. right? It can't see this negative. It won't see it. Why not, Miss Johnson? Because this guy is actually saying the opposite of, and so it's saying the opposite of 3 to the negative second, which is 1/9. So the opposite of that would be negative 1/9. Okay. Try to get this synced. Okay. So here, this exponent actually sees the whole thing because it's in parentheses, and parentheses allow us to see the whole thing. Does that make sense? Okay. Last but not least, number 27, that these negative exponents, right? So again, what I want to do here is I want to say 32 to the negative first means I'm going to divide by a 32. So put the 32 on bottom, Miss Johnson. Yeah, I'm going to put the 32 on the bottom. Just as a placeholder, I'm going to put that 1 on top just so I can placehold it. Now, this 4 to the negative first, follow me, please, means that I'm going to divide by it. But Miss Johnson, it's already being divided. So when you divide by a fraction, do you remember multiplying by the reciprocal? Do you guys remember that? So I'm going to just go like this, just so that this makes sense. I'm going to take this 4 to the negative first, and I'm going to say multiplied by 1/4. You see how I'm dividing in the division, in the quotient, in the divide, and then, sorry, in the denominator. So what happens with that, Miss Johnson? Well, when you divide by a fraction, see, this is the division sign right here, by a fraction, do you remember multiplying by the reciprocal? Oh, so you want me to multiply by the reciprocal, right? So this is equal to 1/32 times 4/1. Ms. Johnson, why did you flip it? Why did you reciprocal it? Because that's what dividing by a fraction actually is, right? You're really multiplying by the reciprocal. So then my total answer is, Ms. Johnson, it's 4/32, which is just 1/8. Very good. Now, some of you already see this pattern and you're like, hey, can I just take the 4 to the negative first and push them to the top and avoid all this? Yeah, but this is just why that works, right? I like to show students why things work, okay? Does that make sense? Any questions? All right, hope you have a great day.